Hello, good morning. It's Thursday, December 12th, and my name's Rob. I'm that developer dad, and I'm working on solving some interesting problems by using .NET and C Sharp. And a lot of these ideas I'm sure you can do in other language stacks. I don't know the words for those other language stacks. And yeah, so I started off, excuse me, I started off working on a little application to help me at my D&D table, and that application grew and grew and grew. It was like a very, very hungry code base, and it eventually turned into something that some friends of mine actually want to be able to use, and I'm sure other people might want to use it as well once it's ready. So I've been since working on all of the goo that I need to be able to automate a lot of the back office stuff. And along the way, I've come across a number of programming things that have always bothered me when it comes to making software happen. And so this week, I've been kind of focusing on solving a lot of those things and just getting them out of my way so that when I'm actually working on the applications, I have all of those things in place, but they don't interfere with the logic that I'm trying to implement in my application itself. So getting all of that goo and architecture and so on and so forth sort of encapsulated and hidden away in this internal framework that I've built, and just adding to that framework so that I can do things much more transparently and easily without having to think about all of the intricate stuff that actually goes on around the feature code. So earlier this week, I worked on a filtering concept that allows me to create arbitrary collections of filter criteria and then execute them against a collection of the type that the filter was built for. And then that worked well. That worked really well. And now I need a way to get that to also work with the way I kind of keep my components independent with their own versions of contracts and so on and so forth. So I'm going to share my screen and I'm just going to pop open PowerPoint so that I can sketch out what I mean here. And I want to add a new slide. Here we go. And we're just going to get rid of this stuff. Delete, delete. And of course, we've got, if you've been following along with me for a while, you know this pattern. I'm going to shrink this down. And we've got up at the top a thing API and a thing manager. A thing engine. And engines are sort of the odd duck here, in that we don't necessarily always have a discrete representation of thing that the engine prefers to do or has to deal with. The big one here is the thing resource access. All right. So the thing engine, I'm just going to fade this guy into the background here. You're just going to fade right on out. We'll even make the outline on it like so. And let's make the text sort of a dim gray. I'm going to go so far as to make the outline on that dashed so that it just kind of fades into the background. Now we've got, in addition to that, well, we've got, and I got to compress all of these, taking up way too much space. Pull these down the screen. Yeah, that'll do. This guy, the engine, you know what? Let's just pull him completely out of band here. Stuff him over here. Need a little bit of space here. And these boxes can be an awful lot smaller. And take up way less space. So here, let's just do that. And I want to change the background color on this guy. Let's make him a nice light green. And we'll edit the text. Make the text black and much smaller. We'll take it down to a 12. Thing, API model. Actually, we're just going to copy, paste, paste, and paste. We've got several different models here. I'm going to call this thing the manager model. This guy is the resource model. And this is the storage model. And by having 4 different representations of thing, this API model, that's the one that the public gets to see when they call the API. This is when they call my API and say, get the thing, they get back a representation of the thing shaped as specified by this API model. Now the manager, it might have a different view of thing. And so it's going to have a different model shape, perhaps, given enough time, definitely, than the API model will. And there's a reason we have this API model out here, and it's to stabilize how the thing looks out in the wild. Within my system, thing might change itself frequently. So every single one of these things every single one of these code artifacts or components needs to be able to transform their version of the thing into whatever. And the direction of transformation always goes down. So when Thing API calls my Thing manager, it's going to get a manager model back because the manager doesn't know how to build a Thing API model. It only knows how to create a Thing manager model. So Thing API is going to say, hey, Thing manager, give me the thing. And the manager is going to do its work to get the thing, regardless of what that work involves. And it's going to send back a version of the thing that the manager knows how to describe. And then the Thing API is smart enough to be able to translate the version of the thing that the manager understands into the version of thing that the rest of the world will expect to see. Similarly, resource access has awareness of 2 models, but it only it kind of controls both of them, but that's fine, because the way we access things, the way things have to be shaped when we store them, we might have to change the way a thing is constructed to stuff it into a database. And thing might have to be, the storage thing might have to be folded up a different way to put it in a file system or send it to some foreign API. So what we do is we hide all of that crap, all of that gushy detail from the rest of the system, because when the storage semantic for thing changes, I don't want to have to change every place in my system that uses thing. So resource access, number one, encapsulates that transformation from what the system thinks a thing resource looks like. That's this guy. Translates that version into whatever version of thing it needs to exist as to be able to be stuffed into whatever resource or storage mechanism we're using. So Thing Manager knows how to request a thing resource from the resource access component. And it's going to get back a thing shaped like a thing resource. And the Thing Manager needs to transmogrify that resource into its own local idiom, its own local version of thing. And this incurs the need for a ton of mapping code. And mapping code, if you've ever written it, is boring and repetitive, and it's really easy to just kind of fall asleep at the wheel and go on autopilot and make a mess of things. You're going to create some really hard to find bugs when you're writing mapping code. I don't care how good you are, you're going to get bored, and bugs are going to creep into your code when especially risky when you're dealing with this kind of thing. Yes, we have tests and we have QA people and we have unit tests and all of that stuff. It's going to happen, I promise. Because the only thing more boring than mapping code is writing exhaustive unit tests. So, all of these different disparate models of what a thing looks like, they all descend, or they're all just different views of the same concept, which is thing. That's a domain entity. And this domain entity has attributes. Now, the thing resource model might have more attributes on it than, say, the manager view of the thing, or even the API view of the thing. And we may even have those attributes manifest as different property names. Now, chances are they're going to be of compatible types within a strongly typed framework like C# or Java, but they're all going to look approximately similar. And having to write 2, 4, 6 extension methods, like so, to manager from manager, to resource from resource, to storage from storage. What if we could decorate the properties and the classes that describe thing for the various local contexts in which thing is used, and decorate the properties of those classes with information from our conceptual domain model? And what if we could do it in a way that the architect and senior developers that are helping to stand up the architecture could specify and build. And once that modeling is in place, what if it's largely invisible to the rest of the development team? What if the only evidence they see of this domain model is some attributes on the data contract classes that they're exchanging between components? And that's exactly the kind of code that I started building after yesterday afternoon's stream. So up in that DeveloperDad.iFX in my SAS admin project, I added a new namespace called domain utilities. And I added an empty class called domain object mapper. That class is no longer empty. And bear in mind, I haven't run any of this code yet. So we're going to be testing and debugging it live. And I've got all kinds of comments in here, blah, 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 blah. And once this is working and tidied up, I'm going to be porting this and the collection utilities namespaces into my main system framework. Hey, what's up, Juba? Yes, I'm talking about DDD, but I'm talking around it because I've got some issues with how I've seen DDD used in the field. A lot of domain-driven development folks just come up with a definition for thing and completely ignore everything else. When in actual fact, our view of thing at the API is likely different from our view of the thing at in the business rules area, and is very, very different from thing in the database. Because thing to you and me as application developers may look very, very different from thing when it's in storage, especially if we've got a Gen X or Boomer database administrator who loves normalization and has split thing into 17 tables. I'm Gen X. My parents are boomers. So yeah, I've worked with those guys. So what a lot of people will do is they'll create this resource model, which is just like the whatever language they're working in model of thing, and it's got everything that you could ever want to know about thing, and they're passing it out through their entire system. And then some project manager says, hey, thing now needs this for the finance people. So you got to add that for the finance people, but then you've also got to plumb that change out through customer service and fulfillment and analytics and all of those other places, because you don't have different facets of thing. You don't have versions of thing that are tailored to the different subdomains of your system. So I'm working in .NET and C#, and I have been for decades. Only a couple decades. So we've got all kinds of good stuff like reflection and attributes and stuff like that to help us. So I created this domain object mapper, and it's chock full of comments about what I'm doing and why I'm doing it and so on. And I've got map, T source, T destination. You pass in the instance of source, and it spits out the destination. And then earlier this week, I created a dynamic filter, which is really neat. That'll be getting into the public system framework repository as well. That allows me to build up a generic filter object against some class, and then it creates an expression, a link expression to filter a collection of that class dynamically as needed. So this eliminates our need for things like get by ID, get by name, get by third cousin's name, get by color of socks, etc., etc. So this is going to help me prevent the exploding API syndrome. And then, of course, there's guard stuff and helper methods and so on and so forth in here. And these are all static methods. So this guy lives in my utility class. So how are we doing this? Let's take a look at map. First thing we do is we have to make sure that tSource and tDestination are equivalent types. So let's take a look at how we're doing that here. So we get the entity name from the source type, and we get the entity name for the destination type. And this guy is in here. We just pass the type. We do a little bit of reflection to get a custom attribute called DomainEntity Attribute. If it's null, out we go. And entity attribute is not null. Okay, good. So if the entity attribute is not null, we pull the entity name out of that attribute and return it. Otherwise, we throw an argument exception. Cool. Let's run back out here to our map. We do the get mappable properties from the type. All we're doing there is just building a dictionary of property infos keyed on the entity attribute name that's decorated on the properties that we want to have mappable. We find the common keys between these dictionaries. We validate that we have something to map between the two types. Build our new instance of the destination type, and then for each key in the common keys, we get its value from our source and assign it to the destination property. And then we return our destination. I've added some helper classes and interfaces and so on. So tSource and tDestination both need to implement iDomainIdiom. We'll take a look at this. And there's just two required properties on iDomainIdiom. We've got entity name and entity properties. And of course, I've created a base class to help add this to the actual data contracts in my system. That just gives us an automatic implementation of those. These are extension methods. We can run in here real quick. And this is just where we look for and return the attribute value or throw an exception. And again, we just look at the properties on the type and we pull back a dictionary with all of those decorated properties. So let's apply this. And to do that, I'm going to close a whole bunch of stuff. We'll leave the customer builder open. Subscription identifiers, I don't need that. So let's take a look at the customer builder and find something. Here we go. I'm doing some stuff with identity. Let's see if we can apply this. So fetch and apply identity. Let's go to the definition. This is where I call out to Microsoft Entra and get the basic identity information for a customer profile. So customer profile, and then we get the identity from the payload, which is a user identity resource. Cool. Let's take a look at customer profile. Go to definition, come back here, and I want to keep that in my IDE. And let's come in here. This is an extension method, and it's user identity resource. Go to definition. Keep that. And we're going to want that mapping extension in a minute. But let's split this to the right and hide these. So we've got a user identity resource, and this represents some aspect of a user in my system. Customer profile represents some aspects of a user in my system. So perhaps this is a candidate. They're basically value objects. Yeah. These guys are candidates, value objects, DTOs, etc. I don't like using the word value object because the C# programmer in me would want to turn these both into structs. Oh, and this is a record. I should probably make this into a class. No, records are classes. Never mind. So I think we've got some good candidates for sort of saying these are what I've been calling idiomatic types of our domain objects. Pardon me. So, domain entity. Excuse me. Name. Wait, it's entity name. And declaring archetype is component archetype dot manager. I gotta spell it right. And bring in the taxonomy namespace dot manager. And there's a third value on this attribute, domain subcontext. It defaults to all, and because I haven't got subdomains in this application, I'm not going to use it yet. So we've got entity name, and I am going to call it a user, call it an application user. So, and I also need to idiomatic type. Import the domain utilities namespace. There we go. Now, I don't know if I'm going to be able to use this same thing over here because I'm not sure if records can participate in inheritance. Idiomatic type. Oh yeah, it doesn't like that at all. User identity resource equality contract. Oh yeah. Yeah, I don't want to use an interface. Oh yeah, interface only. All right, fine. I'll turn it into a class. I was originally thinking I would be able to use records for this stuff, but it's fine. Now, idiomatic type requires domain entity, entity name is application user, but the component archetype on this guy is not a manager. The declaring archetype is resource. And I need to import the namespace, access, save. And we can bring the bracket closers up top there. All right. So let's decorate these guys. And what did I call entity attribute? Entity attribute it's just got the one on it. User ID. Entity attribute display name. Nope. Stop that. Now, already I have exposed myself to a ton of crap. An absolute boatload of unmaintainable code I have just introduced to my previously clean and tidy and easy to work with code base, because I now have to remember what all these damn strings are. And that sucks. I unfortunately am allergic to shellfish. I grew up in Prince Edward Island. One of our primary exports from Prince Edward Island is lobster and mussels and all kinds of shellfish and seafood and so on and so forth. And I cannot eat it. I get violently ill. What is it? Yeah, violently ill. So I cannot enjoy lobster or crab or shellfish or shrimps or anything like that. And having grown up in hockey, additional irony, or having grown up in hockey, having grown up in Canada, and even bigger irony is that I really don't care about hockey. All right, let's get rid of this crap. Now, I've got two framework projects. This is sort of my global. I use this for, or I'm going to be using this for many, 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 if not all. Yes, I did say grown up in hockey. I grew up, I was born and raised in hockey. So I'm going to be using this IFX project across multiple solutions and applications that I write. But I've got another shared library that's specific to this particular application that I'm writing. And I mostly just use this is for constants and so on. So in the sysadmin IFX, I'm going to add a new folder called domain constants. I don't need this project file open here. And inside domain constants, I'm going to add a new file It's going to be a class. Application user. Constants. That works. It will have public const string entity name application user. Nope, I'm going to invert this. Partial class and we're going to rename this SaaS app domain. Cool. Rename this symbol to SaaS app domain. Public class static class application user. X V. All right, now and then we're going to add another class in here to represent the constants for the attribute names. Save this. And instead of SaaS app domain, I'm going to say SaaS app domain, rename application user. There we go. And new file, readme.md, X, it's just a custom file. Yeah. Domain constants, namespace. When adding constants to describe domain models in this namespace, we'll use a partial class called what did I call it? I don't like app domain because that's used elsewhere. SaaS domain. SaaS domain. It will, in turn, contain nested public static classes named for the domain entities that get modeled throughout the solution. Each domain entity class must include a domain entity string constant that gives the name for that entity, as well as an attributes sub inner class identifies the attribute names of the important properties of the entity. Excuse me. These are consumed by classes that represent component classes component code in the data contracts that represent a local idiomatic form of the domain entity. And the system frameworks domain utilities code. There. Just wanted to add a little bit of documentation there. So we've got entity name, user ID, display name. I'll pop back in here. Each entity described in this manner should be in its own file. As a favor to future you and your collaborators, let's use the naming scheme of SAS domain. I need to rename the file itself. Domain entity name. Rudimentary version of this concept would look like this. C#. Hey, take care. Thanks for joining me, Juba. Great conversation, by the way, man. I'm just going to grab this, copy this code into my documentation file, just like that. And I'm going to rename the file right now because app domain means something special in .NET. There we go. And let's just preview it. You gonna let me preview it? No, you're not. I think for that, I gotta come up in here. Here we go. Open preview. Domain constants namespace. Adding constants to describe domain models into this namespace. We'll use a partial class called SAS domain. SAS domain underscore domain entity name. Rudimentary version of this concept looks like that. Beautiful. All right. Now, I've defined my constants. So, I'm just going to leave this guy open for now and pull him over here so that I've got it for reference. I'm going to need to bring in using devdad dot sasadmin dot ifx dot domain constants. Dot SAS domain. Oh, booger off. I bet if I build it. Build. Dot SAS domain. And I can change this entity name because I'm importing a class and I'm just accessing static members. I can get away with this. Otherwise, I'd have to do a public static partial class, and I'm not sure that's legal. So what we're going to do is we're going to come in here and say application user dot entity name. And is that going to work? Oh. DD is for domain design. But I think I want to rename this symbol to entities. I like that better. I like that much better. Yeah. Now we can come down here and say entities dot application user attributes user ID. Ooh, this is pretty. Entities display name. Let's run over to customer profile and do the exact same thing. Using entities equals that exact same thing. Entities dot application user entity name. Entities dot application, and GitHub Copilot is paying its rent right now by just looking at the context of my code files and figuring out, based on things that it's seen me do, figuring out what I want to type next. And that saves me a boatload of time and brain ache. All right, so let's run out to the customer builder. And we load the user identity async profile.apply identity from. Let's take a look at what apply identity from actually does. Pardon me. So profile is null. We create a new profile. User ID, blah, 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 blah. I'm going to comment these guys out. No, I'm not. Come out to my customer builder. profile equals, what's the name of that mapper class? Dot map from, is that going to work? No, it requires two. And customer profile is my output, so I need to give it the, what's the type of the payload on this guy? User identity resource. We're going to comment this out. Oh. Here's an interesting wrinkle. Map always creates a new instance of my destination type and sends it back. And I don't always want to do that. That's okay. What I am going to do right now, excuse me, save this, bounce in here. Go to definition. Oops, I'm already in the definition, you doofus. I want to rename this symbol. Rename map to new. And I'm just going to collapse this just for sake of screen real estate. And I'm going to create just a reminder for myself to do, create a version of map to new that accepts an instance of an existing T destination and simply copies the values from source to dest. Save. All right, let's come out to our customer builder. And I'm going to drop a breakpoint right here. I'm going to come out to my test console and make sure it's doing the things. Yep, it's going to run the actual application that I've got built. Excuse me. I do not need another bloody chest cold. I've got a show to play this weekend. And this dry cough, it gives me the creeps, yo. All right. So we're going to build up our customer profile. We're going to request the customer's identity. And let's step. We'll load it. We've got it. And now, let's try this. Let's take this for a spin. Step in. This is the first time I have ever run this code. So I don't know if it's going to work. So guard types are equivalent, obviously, otherwise it would have thrown up on me. So we'll get the mappable properties. Our source map. We've got user ID and display name. Our destination map. We've got user ID and display name. Common keys. We've got 2. Activator.create instance of our destination. We got it. And then we'll just step over because we've only got two. And our profile now has GeekDad and GeekDad's user ID. Beautiful. Absolutely beautiful. All right. And I've just eliminated the need for a discrete mapping method. Now, this map isn't going to work for 100% of mapping cases. If I can get it to the point where it works for 70 or 80%, I'm going to be overjoyed. We're still going to have occasions where we need custom extension methods to map between objects, especially if the objects are particularly complex and have a lot of nested objects and so on. We're probably going to get to see that happen in our customer profile as I continue retrofitting this domain object mapper into the existing code base. I might be wrong. We might be able to hit all of them, but I'm really skeptical that it's going to work for every case. So we may still need to fall back on good old-fashioned extension methods or traditional mapping code. But that first attempt worked beautifully. I am going to break until this afternoon. I'm going to add that additional method to the domain object mapper where it doesn't create a new instance of our destination, but applies the property values from source to destination for us, and then returns the destination. Excuse me. And then I'm going to apply these attributes to other classes throughout my system. And we're going to see this grow and grow and grow over here in the constants, because we're going to be able to take a peek at, as I work, this application user is going to have things like subscriptions and all kinds of other things. So this could get fun. I might have to alter the entity attribute name thing for when we're dealing with complex properties, like properties that are custom types instead of things like strings and ints and booleans and dates and so on. I might have to do something fancier in there. That'll be okay. That'll be perfectly fine. Yeah. Yeah, this mapping stuff could work out nicely. Now, yes, I'm reinventing AutoMapper and a bunch of other mapping components that are out there, but I've worked with AutoMapper, and honestly, I've found that I prefer to do the mapping code manually in extension methods to using AutoMapper. I might, because I found that AutoMapper is cognitively expensive. You have to learn how to use it, and maintaining the mapping code between objects and stuff, especially if the object definitions are volatile, can get to be more work than just using extension methods. This feels like a happy medium, and the big benefit is if you adopt this technique that I've described and implemented here in that DeveloperDad.iFX, You will own the code. So if you decide to start using that DeveloperDad.iFX in your own projects, I'm not going to publish this as a NuGet package. I'm just going to publish the code. So it'll be up to you to download the code base, change the name spacing to whatever your company's name is or whatever. Like I'm basically saying copy and steal this code if you want to. And then if you don't want to use the domain utilities or the collection utilities, delete them from your local copy. If you decide that this thing isn't for you to use, don't use it. I don't care. If you do use it and it helps you, beautiful. I'm happy. Just send me an email through GitHub and let me know that you've used it and it helped you solve problem XYZ. That's all I'd ask. If you're feeling really generous and you make $1 million using this stuff, maybe buy me some beer. I don't know. I'm kidding. It's all voluntary. This is MIT licensed stuff. So I'm going to get this stuff incorporated. And I'll be back this afternoon and we'll continue applying this domain modeling annotation to other classes in my actual system. And we're going to see how it works. I like to dog food things before I push them over to the main repository. And so far, this dog food's pretty tasty. Until this afternoon, take care of yourselves. This is a reminder to me, eat some lunch, and happy coding. See y'all next time.